Hello, I represent your United States industry, the ethical assessment of PCB. For the beginning, I want to thank my tutor Pierre. He helped me a lot during my internship. Okay, so at first I want to present you the production process of PCB. Here is a PCB, and it's made by the resin, glass fiber, and copper. On the left, you can see in a factory we use the copper fill and prepare a layer to make the PCB. The prepared is made by the resin and glass fiber. And on the right, it's a PCB already good finish, and you can see they make the through hole on it and the solder mask too. So here is the process to make the PCB. At first, you need to prepare the inner layer. The inner layer is the two copper fill and the core always runs the same to the prepared, and then you make your circuit on it by the photoresist, and then you develop the resist and remove the copper you don't need, and rest the circuit on the board. Then you check everything is good, and to put all the inner layer you have together, and then you laminate it with a high pressure and high temperature. Then you can drill it and metallizate the hole with copper. Then it's the outer layer, which is the same as the inner layer. And you can plating the tin or gold on it to make it better for solder. Then at last you have a solder mask to protect the PCB the board to make it better for the solder. And last, you need to separate the whole panel to the small pieces, which is you want, and deliver it to you. To make a electrical assessment is at first you need to prepare the environment and the database, and you list all the raw material of your product, and you can write some Python code to get the results of the analyze. But we have take many times, almost 2 months for checking for searching on the internet and for searching the data. But we found some difficulties. The first one is the different companies use a different technology or the raw material. They sometimes, for example, to clean the panel, they sometimes use a physical way. Sometimes they use the acid solution. So we don't have a general way for it. And the second one is the different company make the PCB for different markets. So, for example, some is for the automobile, sometimes it's for your computer, so it's different for the PCB. And the electricity consumed and the material used are confidential information. That's the worst things for us, because we contact several companies, but we can't get the data we need. So at last, we still find some interesting data in the company's reports, which is some carbon intensity and energy intensity. This data is so general, so it's not really useful, and they don't calculate how many different layers they have. So this is a general information for us, but we believe we can still find something about it. So we stop here about my aim of my start, because at the first we want to make a model about different layer, and we have some inputs like how many layer you want, how many hole you have, and then we give you the result of the left circle assessment, but without the data we have, so we can't make the model like this. Then I begin practical work of the, I would say, is because the team ESOS beginning a course for students, and they have a practical work. So I did this practical work as a student, report to give the teacher some advice for their course, and this is practical work from the cradle to grave. That means from the raw material to the end of the life. So we have a industrial screen, which is STM32MP. It's made by the motherboard and display model which include a display board and LCD screen. In this practical work, in the first part, we use this industrial screen and add some transport and usage information. And the second part, we add a microphone and speaker to make it as a connected doorbell. And we will do some improvements to compare some situation and to show you what the SAVs mean. The first part, here is a 16 impact category you need to know. This is a 6 important category for the environment. They have land use or some water use or radiation and so on. Here is the result of my practical work. You can see this is an impact version for each sub-component. We have the electricity used. Let's imagine we use this product for 20 years and with active whole day's life. And here is the transport and some mainboard production impact. You can see the electricity is the most important element for it. And for we have 3 figures. The second one is normalized impact that help us to compare the 16 categories together. And the last one is the result by categories. You can see the usage, which is electricity, the most important element. And next, we add the microphone and speaker, so it's almost the same. The electricity is the most important one. So we think at the last, we think we can improve some the electricity part for it. So we changed the resource of the electricity. We compare the Polish electricity and French electricity. The Polish electricity is with the coal resource, and the French one is almost a nuclear resource. You can see the situation is better, but in the IR, which is radiation, is worse because nuclear resource make this like that. And for us, it's not enough because it's still more than half of the impact. So I think we can add a sleep mode for this product, because for doorbell we don't need to activate the screen all day. We add a sleep mode which make it 1 hour active a day and 23 hours in the low power mode. So this looks really better for this. So now the integrated circuit is the most important element, and maybe after we can continue to improve it in the future. So this is the end of my presentation. I hope you can understand what is a left circle assessment now.
Thank you very much.
Question?
You in slide 14, you talk about transport. What is the conclusion? What is your conclusion about transport?
Yes, you almost can't see the transport in the figure because the product is too small and it's that you can't weight, you don't have so much weight, so so for compared to electricity, you can almost ignore it. Yes.
Sometimes you show this type of graph and sometimes the normalized one.
Yes.
So when is it useful to use one and when is it useful to use the other?
Yes. For example, for this figure and the third one, the categories one, you can see this one is the motherboard production is the whole motherboard, which is and in the third one you can see more detail because the motherboard is made by the integrated circuit and the peripheral. Let's show you more detail about the card, and the second one is normalized one. You can compare them the 16 categories together.
So if you want to decide what you would like to address, which part of the system you want to reduce?
Right, yes.
So you will use this one, the normalized one?
I would say that everyone is useful. Every one of them is useful. You can have some information about from the every figures.
Okay, thank you.
Any other question?
Yes. During the first part of the presentation, you were saying that you had a hard time finding data.
Yeah.
And in second part, you present result. On which data those results are based on?
We use the data from the database equivalent, which is here is the name of the database, and it's a database of Europe. It includes in fact the data from all the world, and there are a lot of university and company to make this database. So you almost have everything you want on it.
Okay. They manage to find the data. So
Yeah.